Okay, continuing our review of fractions, and we're down here at the bottom of page 2. We're in section 1.2, bottom of page 2 for the notes. We're now looking at the instructions saying simplify each fraction by reducing it to lowest terms. Now, there's lots of different ways to think about how to reduce fractions, and I'm not here to say you have to think of it this way, but there's a purpose in the way I want to demonstrate to you today how to think about reducing, because again, we are headed towards having variables involved in our fractions, especially when you get through 65, Math 65. So remember that algebra works the same as numbers, so as long as you understand the rules and what's happening with numbers and why the rules are the way they are, it'll be so much easier when the numbers just appear and they're replaced with unknowns. There's letters in place of those numbers. So if you learned how to reduce a little differently, that's totally fine. I just want to expose you to what's going to be happening algebraically. And I would encourage you to try it this way so you can start to train your brain for what's ahead. So let's look at number 40. Starts as 116 over 86. Hopefully you're recognizing that as an improper fraction. Not that it's bad, it's just a little top heavy. There's more on the top than there is on the bottom. And so what we want to look for is the prime factorization of both. So what we're really going to do here is we're going to find the prime factorizations and our goal here is to do some canceling of similar numerators and denominators, because what we're really doing is we're going to be factoring out factors of 1 where the numerator and the denominator match each other. And I'll call that versions. We're going to factor out versions of 1, because when you multiply by 1 you don't change the value of anything, but 1 can come in a lot of different shapes and sizes. Let me show you what I mean here. Let's pull 116 out to the side so we can get its prime factorization, breaking it down here. 116 is divisible by 2, and oh, sorry about that. Let me just take a quick peek to make sure I'm still back in business. Good. 2 times 58, 2 is prime, so we're going to stop there, but 58 is even again, so this breaks down into 2 times 29. 2 is prime, so we're going to stop there. 29 is also prime, so we now have the prime factorization of 116, 2 times 2 times 29. We're also going to find the prime factorization of 86. So we're going to break that down. Again, it's even, so we'll start with 2. 2 times 43. And 43 is not divisible by anything. You can go through all the tests that we looked at the top of the page. It turns out that 40... Oh, sorry, I keep moving this. I should tape these down. 2 times 43. So what we have now is we can rewrite this original fraction of 116 over 86 in its prime factorization form. The top is really 2 times 2 times 29, and the bottom is 2 times 43. And the reason why I write it this way, again, so we can start training our brains for the algebra, is what that means is with multiplication, when you multiply fractions, remember you multiply top times top, bottom times bottom. Multiplication was beautiful because you did not have to worry about finding like denominators, right? Whew, those are exhausting sometimes. But when you multiply fractions, we just went top times top, bottom times bottom. So we can undo that. We can look at it, what was it one step before we multiplied by? Notice we have a matching 2 top and bottom. And again, many of you were trained to just cancel those right there and you're at the reduction, you're at the reduced fraction. Again, I'm just trying to demonstrate what's going to happen when we start involving more algebra here. This is a great way to think of it when there's only letters involved. It's as if we had 2 times 2 times that 2 and 29 on the top and the 43 on the bottom. 2 over 2 times that. This is exactly the same thing that we see here in purple, only that matching 2 times 2 has been pulled out. It's still multiplication. We could still mush this back together and get 2 times 2 times 29 on the top, 2 times 43 on the bottom. It's still fractions there. What happens is that the 2 over 2 is really just 1. It's a very powerful one. It doesn't change the value of it, it just changed the look of it. 2 over 2 is really 1, and so now we have the revised fraction here, 2 times 29 over 43. Nothing else matches top or bottom, because remember, these were prime factorizations. There's no way to break these down further. So we can go ahead and recombine and remultiply here, and we end up with 58 over 43. This is the reduced fraction of the original, 116 over 86. It's equal to 58 over 43. It's the same exact version. It's still 116 over 86 that's equal to the 58 over 3. You'd still be getting the same amount of pi if it were cut up into 86 equal pieces and you had 116 of them. Same amount of pi if you had pies that were cut up into 43 equal pieces and you ate 58 of them. Be the same amount. These are just different looks to them. One has been reduced. All the matching factors, top and bottom, have been canceled out or divided out. So anyway, it's just a way to think about it. Many of you may have looked at this problem and finished it hours ago. And that's fine. Just wanted to expose you to what's really happening so that you're ready for the algebra. So take a moment to copy, tell somebody, talk it through, note any questions you might have or comments, or maybe another way to think about it. Always open to hearing that from students, so please let me know if you ever have anything you want to contribute. And then pause the video and you can try number 36. Okay, when you do try number 36, you should end up with it equaling 15 over 16. And again, if you have any issues with these try problems, that'll be where we focus our lecture time on in class, is these kind of middle-of-the-road problems. Not the super challenging, but they're certainly not the beginning type problems either. And then page 17 and 18 give you some reminders in the book, how to reduce a fraction to its lowest terms, fundamental principle of fractions. I really love that this author highlights this. This is the basic idea. This is that power of one that I was talking about, the strength of what you can use that for. If you have a fraction, a over b, and again, algebraic language here, this is where we're headed to be able to do the same things we do with numbers when there's letters involved. The value does not change if you multiply top and bottom by the same non-zero number. Okay, throw 0 in there, it changes everything. But if you have a non-zero number, you can multiply top and bottom of a fraction, and it still will reduce to that same fraction. It still has the same value. You're still eating the same amount of pie. Okay, so that's a good point to note. All right, we'll see you on page 3.